Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on oil network modeling, oil production network modeling, and water injection network modeling. We couple these two models and we run in the GAP software, which is very important and interesting tools. Okay, so that's it. We arrive at this point. In previous video, we have run the prediction and we have saved the prediction. Now I'm showing you the prediction snapshot. So just like what we did in previous exercise or previous topic, I'm showing you the prediction snapshot right now. To show the snapshot, we can go to prediction, reload prediction snapshot, and whatever you want to show in which time step, the results. Don't forget that we make a step size of 2 months. So you can see step change here is 2 months. So currently I'm showing you the February 2012 snapshot. Let's say we move on to August 2012. Click on OK. Okay, so now we move to the snapshot at August 2012. So let's maximize the water injection. All right, so let's investigate the reservoir. By the way, you can see we have two red arrows here. It means that a constraint is being applied and achieved in this particular element. In this case, it is the reservoir. So remember, we have two red arrow symbol, which means that a constraint is being achieved. And what is the constraint? Let's double click on this and go to input. You see here, tank reservoir A input screen. And we can see our constraint is maximum liquid rate, which is 16,988. This is the value, unit is stock time barrel per day, binding yes, potential no. So this is the constraint that is being applied in order to achieve the target pressure, which is 3,650 PSI. Okay, so you set the target pressure and the system GAP will try to achieve that target pressure by making or by applying constraint. In this case, we have one constraint for this particular time step, August 2012, and the value of the constraint is maximum liquid rate of this, almost 17,000 stock tank barrel per day of water or maximum liquid rate. Okay, so that's it. And if we are interested in looking at the results, we can expand this window. And then let's just, if you're interested, you can check all the results here. And let's plot. Okay, let's focus on this case, prediction with water injection system. Let's plot reservoir A, reservoir pressure. All right. And then also we plot the average water injection. Okay, so let's see, we have actually the target pressure of 3,650 PSI. But something occurs here. The reservoir pressure drops below 3,650 around February 2012. It drops down to 3,635, just a little bit, but then it increases again and we can achieve again the 3,650 target pressure, but something's occur again here at this time step. All right, so you can see why this is different with what we want. What we want is actually the target pressure of exactly 3,650. So actually it must be just a straight line, a constant straight line, a constant value. But after we run with water injection network, we cannot achieve the target. Why? Because indeed the current model cannot deliver what is required to maintain the reservoir pressure exactly at 3,650 around this time step and around that time step. Okay, so it means either you need bigger pipe or you need bigger tubing for your well. You need to investigate it deeper. But this current model tells us that we cannot receive more. And thus, because we cannot receive more, because the reservoir cannot receive more, or because the system cannot inject more water, we cannot achieve the target pressure of 3,650. If your model can give more, can inject more, like, for example, if you have bigger tubing or bigger pipe or pipes that are cleaner, less friction, then maybe you can inject more, and thus you can always supply the necessary water volume in order to maintain the pressure at exactly 650 psi. So this kind of observation and investigation is very, very important for us before we really design our water injection network in real world. Okay, so I think that's all. And this will effectively close our series of the combination of oil production network and water injection network. So it is good if you want to save, just click save, and we can close, or here, sorry, snapshot loaded, a prediction snapshot has been loaded. Okay, okay to proceed. And then we save. All right, and that's it. So we can close the series here. We learned so many things about oil production network and water injection network, and hopefully in the future we can have other topics to learn in GAP. But thank you so much for following up. See you again in the next GAP video. Thank you.